In the time that is left to the break, I think we have a break at 3 o'clock. In the time that is left to the break, I would like to start talking about the next topic, that are prediction methods. Prediction methods are, as the name states, methods to predict the coverage or the electrical field distribution or the power density distribution, whatever you like, over a given environment. Now we start mainly focusing at the moment, for the time being, on rural environment. We will move to urban environment later on. Now, what are those prediction methods? The prediction methods are, they try to do one thing. They try to calculate, to predict the median field strength. Median over a given area. We will discuss later what is the size of this area. But usually is in the order of 500 meters times 500 meters. Or 100 meters times 100 meters. It is not possible to predict the electromagnetic field in a precise point in space, because there are too many variables that are unknown. If you try to calculate the electric field inside this room, for example, in theory you could do that. In practice you should know every single detail of this room, of the furniture, of the wall, anything. Because it's sufficient. If I move this table, if I take this table and I move it by 10 centimeters, the field distribution inside this room changes. So what we can reasonably do is try to predict the median that is close to average field inside an area. And we can do this in several different ways. We will discover that the median value is not enough, because the median is median, but it describes what happens for 50% of the time, or the area in this case. But we would really want to know what are the fluctuations around the median value. But we will go back to this later. So, let's start classifying the methods. Then we will go into the methods maybe later or tomorrow. We have two big classes of methods. Well, actually there are four, but they are combined in a way that they are actually two. First of all, we have empirical or physical methods. Empirical means they are constructed from measurements. You do a lot of measurements in different environments, different situations, and you try to construct some functions, some models that interpolate your data. You don't try to understand the physics too much, or you don't try to understand the physics at all in empirical models. You just make experimental results and construct some models out of those measurements. Physical models, they are based on physical theory, on electromagnetic field theory. We shall see that it's not true that physical models are always perform better than empirical models. This is not necessarily better than this, for a reason that I will explain soon. Their output, what do they predict? They can predict some statistical quantities. That is, they provide you only with statistics of the main parameter. For example, field strength. And this is done for a generic environment description. What do I mean with this? I mean that in this model, your input, your geometry is described very passively. You say, okay, give me a prediction for a highly urbanized area or for a rural area, but you don't actually input into the model how your building is made. You just say, okay, this is the high-rise building area, and in that way, it gives you a statistical description of what you may expect for that environment. The output can be deterministic instead of statistical. That is, those parameters, the main propagation parameters, are calculated for very specific environment configurations. For specific environment configuration. That is, you describe your actual scenario to the model, and the model tries to calculate the propagation parameter for that kind of scenario. That kind of buildings, that size, that height, etc., etc. Usually, empirical model can produce mainly statistical results, to produce deterministic result, you need physical models that have some physical basis in it. So when you look at the models that are available to predict your coverage, you will find the so-called empirical statistical models or physical deterministic models. Before we move to the break, I want to show you something on a complexity, plane of complexity.
Gracias.
Okay, if you try and classify the models, on this axis you have complexity. Heuristic models, or let's say what we call it empirical model, are the simplest. Physical models are more complex because you need to put a lot of physics in them. On the other side, there is what we call database cost, and I will be back to this in a moment. Statistical results require very low cost databases. Deterministic model to produce reliable results require a very extremely accurate and therefore costly database. When I said there is not true that physical models are necessarily better than heuristic, is that because for any model, for anything that you use, any simulator, any model, any whatever, there is the old saying, trash in, trash out. If the input data of your model are trash, what you get are useless results. So there is no point in using a physical model if you don't have the input data, a very highly accurate description of the environment, because you could even get worse results than using an heuristic model. So, what is mapped on this complexity plane are the different models that we are going to see. We will start looking at ATA-like models that are heuristic statistical. Then we will see over-rooftop models that are mainly, those models here are pretty much suitable for rural environments. Over-rooftop model is models the propagation, as the name says, over rooftop in urban areas. And then we see something of ray models, ray tracing, ray launching. We will not look into pure electromagnetic models because they are just too complex. But please keep in mind when you use any model that you are going to use, that the model is okay, but it's most important to have the right input data. Otherwise, what you get is useless. Okay, we shall stop here. I think for the rest of the afternoon, we do applications to these exercises. So we practice, we put in practice, we apply what we have seen in theory. Questions? Okay, go for the break.
Ese cubano, ese cúbico. Cúbico. Ese es cubanazo.
Ya digo, yo soy el Chávez. That's big. No voy a hacer la experiencia.
Yes, you will start with this. Yes, this is usually applicable for buildings.